Why do diamond, graphite, and charcoal have different energy states? Imagine holding three pieces of carbon in your hand. One sparkles like a jewel, another feels soft and powdery, and the third is black and crumbly. Why do these three forms of carbon behave so differently? The answer lies in how their atoms are arranged and bonded. In diamond, each carbon atom connects to four other carbon atoms with very strong covalent bonds. These bonds form a tight, three-dimensional network that makes diamond incredibly hard. Because of this rigid structure, diamond stores a lot of chemical energy in those strong bonds. It takes a lot of energy to break those bonds and change the diamond into something else. That's why diamond has a high energy state compared to other forms of carbon. Graphite is quite different. Its carbon atoms form flat, hexagon-shaped sheets. Each atom bonds to three neighbors within the same layer using strong covalent bonds. The layers are held together by weaker forces called van der Waals forces. These weak forces allow the layers to slide past each other easily. Because of this layered setup, graphite is more stable and has a lower energy state than diamond. The electrons in graphite are free to move within the layers, which helps it conduct heat and electricity efficiently. This delocalized electron system also makes graphite more thermodynamically stable at normal temperatures and pressures. Charcoal is mostly amorphous, meaning it lacks a clear, organized structure. It contains a mix of disordered carbon atoms and small regions that resemble graphite. Since its atoms are arranged randomly, charcoal generally has a higher energy state than graphite. Its energy can vary depending on how it was made and its exact composition. When charcoal burns, it releases energy because the carbon atoms are in a less stable, higher energy state. Burning charcoal converts stored chemical energy into heat and light. From a thermodynamics view, graphite is the most stable form of carbon at everyday conditions because it has the lowest free energy. Diamond is considered metastable, which means it is higher in energy but remains unchanged for a long time. The transformation from diamond to graphite requires overcoming a large energy barrier, so diamonds do not spontaneously turn into graphite. That's why diamonds last forever, even though graphite is more stable overall. In terms of heat transfer and chemical energy, these differences mean that diamond stores more energy in its bonds and needs more energy to break apart. Graphite's layered structure makes it a good conductor of heat and electricity, and it is more stable energetically. Charcoal, being less ordered, can release energy quickly when burned, making it a useful fuel. These variations in energy states show how atomic arrangements and bonding influence the stability and energy content of different forms of carbon.